Okay, this is number 7 from the review pack on differential calculus. It is, in all honesty, a question that I have used for a couple of years with students, and it's always the one that confuses students, so I'm glad someone asked. So we've got a trash can with a cylinder with a hemisphere top, so half a sphere. Trash can has a height of 70. The base radius of both the cylinder and the hemispherical top is 20 centimeters. We need to know the height of the cylinder. So the cylinder height is going to be the height of the trash can minus the height of the hemisphere. So that is 70, take away 20, so 50 centimeters. That's why that's a 1-mark question. So we got A. B, total volume of the trash can. All right. Well, the volume of the can, if I just sketch it here, is going to be the volume of half a sphere plus the volume of the cylinder. Well, the volume of a sphere, that can be found in your formula booklet, but it is 1/2 times 4/3 pi r cubed plus the volume of the cylinder, and the volume of the cylinder is the area of the base times the height of the cylinder. Okay, a little bit of math here. We end up with 2/3 pi times 20 cubed plus pi times 20 squared times that 50 that we found in the first value. And again, there is no reason to do this. Don't do that to me. There's no reason to do this without our calculator. So let us, there's a calculator page. All right, so 2/3 times 20 cubed times pi. Again, if you need to find the pi button, it's here, and then you just click there. And then we're going to add to that pi times 20 squared times 50. So this gives me that absurd number there, which is the correct answer, I think. But, sorry, if I click up, I click on that. If I want a decimal, there has to be a decimal in my response, and that will make that happen. So I'm happy with either one. Let's go with that first one, 76,000 times pi over 3. That will work. And that is centimeters cubed. Sweet. So we got that. Again, you could write that down as that number that it was given. You would have to use the approximately equal to. Designers asked to produce a new trash can. The can will be asked to be in the form of a cylinder with a hemispherical top, height h, and base radius r. There's a design contest, and that has to be that. And we're trying to maximize the volume. Okay, so we know already that the height of the can itself is h. So we also know that h plus 2r has to be 110 centimeters. And we're asked to find the height of the cylinder itself in terms of r. Well, the height of the cylinder, just like with that first question, is going to be the total height minus the radius, right? But that's not quite only in terms of r. That's in terms of this h as well. So I'm going to use this formula here to turn that capital H into a function in r. So to do that, h plus 2r is equal to 110. So h equals 110 minus 2r. So now, substituting that in, I get the height of the cylinder in terms of r is 110 minus, in this case, 3r, because negative 2r minus another r, that's where we get. Tick. Show that the volume of the new trash can is given by that. Okay, well, that is just going to be taking this thing that we derived before and now substituting in my new value for that and simplifying. So if I take that, which again is 2/3 pi times whatever the radius is cubed, plus pi r squared times 110 minus 3r. Okay, now I just got to do some expansion and simplification. I got to expand this through that bracket. So that would turn into 110 pi r squared minus 3 pi r cubed. And then gathering like terms plus, so that'd be 9. So negative 7/3 pi r cubed plus 110 pi r squared. I am beginning to think that we've missed part of this. Uh-oh, that is not at all what I was looking to get. What have I done wrong? It feels to me like something is missing from this thing. Feels like this is missing something. Because I am very confident that I have done something wrong. Okay. What did I do wrong? Oh, goodness gracious me. That's right. We get a square there. Pretty good with that. What in the world went awry? I'm pretty confident that that is my correct answer. I'm wondering if I think there's something wrong here, because that doesn't make sense to me at all. That doesn't take into account the radii and the cylinder. I think there's something wrong with this answer. And I think that's where the problem is. Once you've done that, you would graph that and you would see what the maximum is. Man, that bothers me. But like I said, I'm fairly confident that prompt is just wrong, and for that I apologize. Um, yeah, that prompt just has to be wrong. Negative 7/3 times option pi, times option pi times x cubed plus 110 option pi times x squared. What is wrong? Why are you not working for me? Try this one more time. Negative 7/3 x cubed times option pi, that graphs, minus plus 110 times x squared times pi. All right, so this is a pretty interesting graph. Menu, we need to zoom way out on this. There we go, we're getting closer. Okay. Can barely see it. So menu, window zoom, I'm going to zoom box, and I'm going to pick that right there. I'm just going to scroll up until I find that magic point. Wow, this is way up there. And that makes sense because our original value was like 76,000. So I'm going to find it, but we have to think about what we did before. So I'm going to do -5. It can't be higher than 110. So I'm going to put 100 in for my x max. I'm going to put 10,000. It was 76,000. So I'm going to put 100,000 in there. I'm going to put -5 here. And then let's do 100,000 and see if we get it. Here we go. Now we're closer. And then menu, analyze graph. We're going to try to find the max here. And that says that the maximum is when the radius is 31.4. We've got that. The value of r, got it. So now we just need to check to see if it's 40% greater than the original. To check to see if it's 40% greater, we're going to take this number and we are going to compare it to the original number, which was here. So it's just checking, is that number 40% bigger than that one? Okay. To do that, this is f of 3, 31.4. I'm going to go back to a calculator page. F of 3 of 31.4 gives me that crazy number. And I am going to take 76000 option pi divided by 3, and I am going to divide that answer by that answer. And what we see is that this value is 69% of that. So it's not quite 40% bigger, right? Because it's only 69%. We could do it the other way and we could see that it won't be 1.4. But that is the general way of doing that. And again, I apologize. I think that there was a mistake with where that's written. Let's look at the mark scheme. There that is. Yeah, look. See, in the mark scheme, they have what I had. So it's just an issue with the prompt. I apologize for that. Anyway, I hope that's somewhat helpful. And good luck.